This is a stepper motor position and speed controller. We have a PIC 16F84 controlling everything. We have 4 normally open push-button switches. We have another switch that puts us in and out of speed control mode. The speed of the motor is controlled by a potentiometer. We have an external A to D converter. It's a National Semiconductor ADC0831. It reads the voltage from the potentiometer and sends digital data to the PIC. We have 2 LEDs, one to indicate that power is applied, another one to indicate whether or not we're in speed control mode. We're using ELAB's EDE 1200 unipolar stepper driver and a chip with Darlington transistors. That's a ULN 2003A. And those send pulses to the stepper motor in the proper sequence. Okay. The 4 position buttons position the motor at the current position, that's the first one, at the 45-degree position, the second one, at the 90-degree position, the third button, and at the 180-degree position, the fourth button. So they're removed from the 45-degree position and back to the 0-degree position. That's the fourth button, which moves to the 180-degree position. And you can see the motor taking one step at a time. This particular motor has 7.5 degrees per step. Okay, now to enter speed control mode, we press the other button. The red LED appears, indicating that we're in speed control mode. Now the potentiometer is active. If you turn it to the right a small amount, it's turning the motor clockwise. And as we turn it further, it increases the speed of the motor by decreasing the pause between each step. We can also turn the potentiometer counterclockwise and have the motor turn in the other direction. Again, the speed is proportional to the potentiometer displacement. Now we're back in position mode. The speed LED is off, but the speed we're running at, which is very fast, is used to move to the index positions. It's important to note that that was a very fast speed, and if you try to move to the positions starting at 0 speed and immediately go to that fast speed, it cannot track properly, and the motor does not move the full 45 degrees, or in this case the full 180. So you just buzz in that one place because the motor is stepping too fast for the rotor to respond. If we go back into speed mode and move to a slower speed, and again enter position mode, now the motor can track the positions starting from 0 speed. Again, to move a stepper motor at a fast speed, you have to gradually accelerate to get to that speed. You can't start at that speed immediately.